Hello everyone. For this week's tutorial, I'd like to go over the basic spectral effects, which refers to the audio effects that specialize in the human hearing spectrum, i.e. the frequencies that go from 20 Hz to 20 kHz. When I said basic spectral effects, I was referring to effects that only touch on one frequency as an input, as opposed to effects that use multiple frequencies at once for their input, which is what I will save for the next tutorial. Every sound in the world is composed of a fundamental frequency and harmonic overtones, which refer to the pitches that give the sound its unique characteristic. With enough practice, you can be able to distinguish the lower frequencies in a sound versus the higher frequencies, which is what you will need to do if you want to work with spectral effects. However, you do not have to stress out about knowing the exact harmonic frequencies, because most of the time, the spectral effects aren't that precise, and usually let you cover multiple frequencies at the same time. For example, once you have made your recording, as usual, you can start with the most basic of the spectral effects, the low and high pass filters, which are on the bottom menu, and simply cuts off all frequencies below or above the specified frequency by a certain decibel amount, with the low pass filters cutting the frequencies above and the high pass filters cutting the frequencies below. The two parameters are the frequency you cut off at and the decrease in decibels per octave past the cutoff point, where the definition of an octave is the frequency either twice or half the frequency you are cutting off at. So for example, a 6 decibel roll-off per octave means that in the case of low-pass filters, every frequency twice as high will lose 6 decibels. And in the case of a high-pass filter, means that every frequency half as high will lose the amount specified. Right now, because the roll-off is pretty subtle, you don't hear much of a difference. Once you have made your recording, but once the roll-off becomes the strongest amount supported by Audacity, 48 decibels, you should hear a more noticeable difference. Once you have made your recording, notice that the sound feels more punchy, i.e., you hear more of its bass frequencies than you do its treble. If you set the frequency low enough, it will sound like it's coming from an AM radio. Once you have made your recording, because it is cutting off almost all the midpoint and high frequencies. The downside to this is that if you have a very, very, very low frequency, your sound will have very poor quality and sound muffled. And by similar reasoning, if you use your high-pass filter too extremely, your sound will sound very faint because there's almost no frequencies let through. The next filter is the notch filter, also called the bandstop filter, and it is called that because it stops a specific group of frequencies centered around the frequency you specify. So it works differently than a lower high-pass filter, but it's still pretty simple. In particular, the customizations you have once you click Effect and then Notch Filter are frequency that the notch filter is centered around, and the quality, which decreases the width the greater the quality, for a more sharper or narrower effect. The final type of basic spectral effect that uses only one track to work is called noise reduction, and is the most sophisticated out of the basic spectral effects that only use one track. If you attempt to use noise reduction for the first time on your track, you will be prompted to get a noise profile, which does not let you determine any inputs, but instead lets the software take care of it for you. Any group of sounds that have similar profiles and are right next to each other, such as the sounds from wind or car traffic, are considered noise, and so are added to the noise profile. Any places where there is a sudden change in the quality of the sound, however, such as in the traffic example, loud slamming of car doors, does not get added to the noise profile. The algorithm requires a minimum of 2048 samples, which at the 44.1 kHz sample rate means that you will need approximately 0.05 seconds of audio in order for the noise reduction to register it. And anything below 2048 samples will give you an error message. Once you get the noise profile, you have different options, with the noise reduction being one option, meaning the decibels the noise will be dropped by. Sensitivity refers to how much of the sound is considered noise. So a low sensitivity means that it won't pick up on much sound, whereas the maximum sensitivity means that it will pick up on almost all the sound sampled indiscriminately. And the number of smoothing bands refers to the sample rate divided by 2048. So at the 44.1 kHz sample rate, this means that each frequency smoothing band would have exactly 21.53 Hz. Therefore, a greater number of bands means that there is more smoothing overall of the sound. Here's an example of increased noise reduction at default smoothing band number and sensitivity. Once you've made your recording, notice that the audio is very faint, almost inaudible. Here's an example with the noise reduction back to normal, but the sensitivity maximum. Once you have made your recording, notice how all the sound is picked up, instead of just the parts that have consistent sound. And here is where the final parameter is increased to the maximum, and the other two are held constant. Once you have made your recording, notice how the sound is smoothed out as much as possible, but not exactly reduced by a hard amount, like with the noise reduction parameter. The final option is two buttons and not a parameter slider, with the first button, reduce, being the default option, which simply reduces the sound as normal by the parameters you set it. And the second option is residue, which ignores the parameters you set and instead keeps the sound as is. This may seem useless at first, but can actually be useful if you want to pre-test your noise reduction options before you damage the audio irreversibly by actually applying them. Now that I've gone over the most basic spectral effects, I can go over the more sophisticated ones, which lets you filter based off of multiple frequencies at once, rather than simply one frequency input. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.